Thanks very much, everyone, for coming. It's my great pleasure today to talk to you about Project Springfield, our opportunity to bring unique technology that's been used in Microsoft for almost a decade into your hands, and then to tell you our story of how we brought it from a research idea into impact. So Project Springfield helps you fuzz code before hackers do. Fuzzing is a kind of security testing technology that is uniquely effective at finding serious issues inside software. And we'll talk a lot more about how it actually works. But first, I want to give a little bit of a timeline as to how this technology has come from the research lab into the hands of customers. And now today, for the first time, we are announcing a preview where you can get access to Springfield. You can go to this link, sign up, put your information in, and get access to this technology for the first time outside Microsoft. Project Springfield works to find million-dollar bugs. Now, how many people here have had their laptop reboot thanks to a patch? Okay, a lot of people. How many people here have had a system go down because of some bug in code that they wrote or code that they bought? A lot of people. We call these million-dollar bugs because they're bugs that they're serious, they affect your business, and they're worth investing to prevent. And in 2007, Patrice Godefroy, our chief scientist, who's here in the audience, and his team came up with a technique called white box fuzzing, which we'll talk about, which was research, an idea on how to find these million-dollar bugs. And then by 2009, this technique had found a third of the security bugs during the development of Windows 7. In 2013, we were able to run it at scale on multiple Microsoft products. And then in 2015, we said, what will it take to bring this research into the hands of our customers? What will it take in order to go from an idea that's been very successful inside Microsoft and get it really out there into people's hands? And that's when we said, we can use the power of Azure to bundle us up into a cloud service and use that cloud service to make it available on demand to people outside Microsoft. And that's when William Blum, who's also in the audience, joined to lead a team to build that cloud service and really put together an engineering muscle to sort of say, here's how we deliver this unique research technology to the world. Now, by May 2015, we had our very first version of the cloud service live and the first customer finding bugs with Project Springfield. And you're going to hear some of those stories. And then we've been continuously improving with the help of some customers and partners under NDA. And today, again, for the first time, we're making this available as a preview for everyone to sign up. So the way that I'd like to run this session, we've been working with customers and partners from the beginning. We've been taking people, showing them what we've got, getting their feedback, saying where does it go to the market, how can it help people's needs. What I'd like to do in this session is I'd like to invite some of those people to come up and share their stories with you now. I want you to learn who they are, learn their point of view on security and where they see the market, and hear their experience with the project. And then I'll do the standard Microsoft demonstration tech explanation. Now, what I also just want to say is, we're not going to have a big Q&A at the end just because there's so many people, but what will happen is the speakers will all be here, so you'll have the opportunity to come speak with them, meet with them, talk to them, and arrange follow-ups right after the session ends. So with that, I'd like to please welcome to the stage OSI Soft, Mike Limley and Weston Kurlanchik. If you could come up and just talk to us a little bit about your experience and where you see security and what it is that you do.
Any better? There we go. Hey. All right. So thanks. OSI Soft, many of you have probably not heard of our company. We are a world leader in the acquisition of data from industrial control systems. So some of the systems that we gather data from are critical infrastructure. So for example, nuclear power plants. And security is very important to us, and hopefully to you too, knowing if your power comes from a nuclear power plant. I think that we can all understand the implications thereof. So our company became very, very interested in the security development lifecycle process that Microsoft used. We've been a Microsoft partner for quite some time. And as part of that process, we developed a security advisory board. And I'm on that. I represent development. So my job is to make sure that the development teams at OSI Soft, we have around 30, develop and use good security development lifecycle processes. So, and one of the things that you need to do as part of security development is to verify your code through a technique called fuzzing. And the barrier to entry on fuzzing is very high. You have to spend a lot of time to get your teams up and using fuzzing. And we have had some success with some of our more mature teams on using fuzzing techniques, but it was costly. They had to spend a lot of time investing in the process to get it up and running. And the value was found very clearly through those experiments and uses of it. But it was very difficult to convince other teams. And as my job as advisor, I can't dictate to the other teams, but I try to coerce and convince them to adopt the process. So we got involved with the Microsoft Springfield project, and I believe we got all the teams together. We have on each development team, they have what we call a security champion. That is the term that Microsoft uses for the SDL process. And we challenged them to try and use the tool and fuzz their projects. And I think it was like 5 or 6 of the teams were able to actually use the tool and start finding bugs. So that was a very successful event for us, and we were very happy with the results, and we've continued to use the tool since then. And Weston's going to talk about some of the experiences that his individual team had with using the tool.
All right, is that working? Yeah, great. So hi, my name is Weston Kurlanchik. I'm a senior software engineer in reliability for our core libraries team. Our core libraries team is focused on network, security, and our base data types. So we've been using fuzzing for actually quite a while at this point. We got interested in basically what was before Springfield came up. I think it was called Sage. And we heard about that at DEF CON, or at Black Hat, probably around the 2013 timeline that David had on there earlier. So what we had before was basically, you heard David mention white box fuzzing. We basically had black box fuzzing before. It was more like gray box. So you basically could tell the fuzzer about what types of data that you're going to put in. It would know it would have some information about that, and then it would go and it would do the fuzzing. So the problem with that was that it was a very manual process. As engineers, we'd have to look at the data that was coming in, figure out what the structure was, program that all into something that kind of looks like a big XML database or a big XML document, throw that into the fuzzer. The fuzzer would then go on and do the fuzzing of the data types. So that's actually quite good for kind of our simple data types. So we did that on our base libraries. But the thing was, once we started getting big data structures, so we have this really big memory mapped queue. The queue is several pages. Each page has a header. The header has information that links down to all the individual elements throughout the page. And then each of those individual elements are then also linked to each other. So the problem with that was that in order to put that into the fuzzing solution that we had before, I think would probably take about 3 to 6 months in terms of just developer time, and that's like the only thing that they're doing. So the thing that we were really excited about with Project Springfield was that since it was a white box fuzzer, we could basically just run our test suite. We would generate a bunch of files that we were already sort of testing, and through that, the Project Springfield would figure out basically the structure for us. It would do that 6 months development time in terms of figuring out the fuzzer, and then it would also go through and then find all the pathways in our code. So it was a way to tackle a very difficult data structure and actually a very difficult part of our code. All right. So I'll talk about how we kind of used it kind of in our life cycle. So first, we would, like I said, we'd basically run our test suite, generate a bunch of test cases, and then basically give it and upload it to Project Springfield. Project Springfield would run multiple fuzzers and give us a ton of data. So we found a couple bugs. And so what we do is then we go back, we'd verify that they are in fact bugs. We basically had a couple classes of bugs. Some were expected, basically expected exceptions. So basically it was a time where there was this big queue and it was totally corrupted, and we basically have to throw our hands up and be like, we can't do anything more with this. We basically have to throw. And I know that's not the greatest thing, but sometimes you have to do it. So, so we did that, but we did find some real bugs, some real situations where like, hey, we never thought we could get in here, but apparently the fuzzer found a pathway to get here, and there's a divide by zero. Oh no, that's terrible. So we fixed that. So then that would be, so we identified the high value bugs, which would be kind of step 3. Then we'd go back and fix them. And yeah, so we'd fix it, and then we'd go back and upload the binaries. We'd keep going round and round. Basically until we hit 0. So, so Springfield was a really important tool for us in order to get these big data structures, these big complicated structures to get to the code that was really hard for us to get to without a tool like Springfield.
You know, one of the nice things about it too is that one of the things that developers will complain about is just getting the computer in order to do the fuzzing, and they would tie up a machine for like a month doing fuzzing testing.
Yeah, so it was nice to be able to do all the work that we needed to do on our side and then give it to Microsoft, not have to worry about provisioning machines, not have to worry about how long it's going to go up for, not having to worry about the quote-unquote art of fuzzing, which is basically how long do you run it for. Yeah. They took care of all of that, which is great.
It was right. And as opposed to the fuzzing we would do, which was on one machine, they spin up multiple machines in order to optimize the amount of time. Yeah,
so basically the scale and the way that it went about fuzzing was of huge value to us, and we couldn't have done the job that they did by ourselves. Right. It was not possible. Yeah. So cool. Yeah, we're definitely in debt for them for that.
Yeah.
Great. And I'd like to invite up Chad Larson from Leviathan.
Test.
All right. Everybody hear me okay? Fantastic. Well, thanks so much. I am Chad Larson. I'm the Director of Technical Services for Leviathan Security Group. In the audience with me, I have Chad Thunberg, who is our Chief Operating Officer. As I mentioned, we are with Leviathan Security. Our organization is we're a 10-year-old company, and we specialize in risk management and information security. We are a team of engineers. We have researchers, but all in all of us come from a background of development. And our customer base is the Fortune 10 to boutique. And the reason why we can say that we are up in the Fortune 10 with a small 35-person company is that we focus on very hard problems. We see security as an opportunity for our clients as opposed to costs. And when I talk about the things that we work on, we like to talk about the reasons behind that and our passions for the work that we do. I- If you have experience in information security penetration testing, it's really become transparent that current industry standard practices no longer meet the needs of its clients. A typical penetration test will go from a time-boxed engagement where security practitioners come in, they take your application, they go away, they come back at the end, and they produce a book of bugs, right? We do not focus on volumes of vulnerabilities. We focus on maturing practices. We like to focus our efforts on the developers. And this starts all the way down at the vulnerability, where we're talking about very specific reproduction steps. We're talking about where in the code these vulnerabilities exist and how to actually fix those vulnerabilities. So when we actually talk about bugs with our clients, we're talking to the developers specifically about those, and that way they can go and fix them. When we have this body of knowledge, we're able to then develop trends about how their software development lifecycle practices are influencing the instances of these bugs and where they might be able to fix those. And so we focus on leaving behind enablement, not books of bugs that really only function as doorstops. Our customers come to us with a multitude of challenges. We've seen all manners of problems. But many of these top reasons that customers come to Leviathan Security is that they lack the specialized resources available to do this type of testing, and they can't scale to do it. We actually wrote the book, if you will, on the scarcity of information security talent in the industry. And that's the link you see here at the bottom. This was in collaboration with Google, and it discusses the challenges of hiring sufficient security talent. It's called the Scarcity Report. The second is that security is a cost center. Again, when we talk about industry, right, we see that industry has misplaced expectations on its clients. For instance, why would we expect that somebody who manufactures brakes or brake pads for an automotive have dedicated resources to information security? Right? It's an unreasonable expectation. What this leads to is interrupt-driven information security practices. And so often the question is when clients are coming to us looking for help, they have this question about, well, how do we operationalize these costs? And that's exactly the solution, right? So when we talk about Springfield and we talk about Microsoft and we talk about OSI, we're talking about partnerships. We're talking about partnerships that, with our joint expertise, leads to integration of very sophisticated and powerful frameworks. We look back at that scarcity thing, and we say, if you look at a framework and something that you can operationalize, you really, during the development process, can eliminate those humps and the specialized requirement for security resourcing during the development lifecycle. If you have a framework that automatically performs these testing as you're writing code, right, then you don't need to have an information security practitioner coming in and testing half-developed code, which is actually not a very good use of anybody's time. So really, you look at a new security development lifecycle model. You look at a security practitioner coming in at the beginning, providing architecture and overview guidance, doing things like threat modeling, and then maybe just periodically checking in and reviewing the vulnerabilities that are being produced through the framework that you've implemented on Springfield. And then, of course, at the end, you come in and actually do a full vulnerability assessment penetration test that analyzes the business logic as well. And what this does is it distributes the workload, right? So then devs can focus on all bugs and not have security interruptions. So we took a hard look at two very specific cases for us. And in this particular instance, we have a very mature software development organization, and they have us as part of their software development lifecycle, wherein we come in and perform penetration testing. Now, this particular organization was a bit averse to performing automated testing, if you will. And so we took two of our most recent assessments, and did an analysis. We looked at the vulnerabilities that we found as security practitioners, and we looked at the vulnerabilities that could be found through a program such as Springfield. And in two very like instances, and these are in the past year, we noticed that in the first one of 30 overall vulnerabilities, the framework would have found 9 of those vulnerabilities. And in the second one, 24 total vulnerabilities, the framework would have found 3 of those. So on average, we've got a 21% coverage just using strict automation. And I think anybody who looks at that from a business standpoint would want a 21% return. And so what we see in that first assessment is that you can highlight the efficiency of finding these bugs, getting back to that framework. The second thing that we looked at was a software development lifecycle entire assessment. So over the lifecycle of 18 months, performing multiple vulnerability assessments and penetration tests, we identified 464 bugs in those 18 months. So again, if we get back to that other number, at 21%, we're scaling that back significantly in terms of months of assessment time. And this is actually a perfect example, right? So if you go to the website that was up before on gaining access to the preview, you'll also see OSI Soft and Deschutes Brewery. On there is a case study and a pretty quick video that talks about the benefits of these types of partnerships. And the 3 things that we got from looking at some of these partnerships is, again, it's ease of use. As you heard the folks before me talk about, they were able to go from an old model where it took them 4 to 5 days in writing a fuzzer to, with no results, to on-demand services. The second is speed. Again, we're going, within hours, we're finding hundreds of bugs. In the example that's the case study, they went through 5 cycles of that rounding of upload, fuzz, identify bugs, remediate, 5 cycles to 0 vulnerabilities. And the coverage in that was 2 days worth of work, right? And many results, as opposed to in the old service, they were fuzzing for 3 weeks, finding no results. Now, this is something that we are not only suggesting our customers themselves implement, but we are actually using the Springfield service for our own research and development and our own products that perform security services as well. Low 10, if anybody is interested, we can talk about that after the fact. Thanks, and I will go ahead and invite up the next folks from E&Y, another Chad. This one is on. Okay, great.
Good afternoon. Good afternoon, everyone. So my name is Chad Holmes. I am a cybersecurity leader for the EY cyber practice. Prior to coming to EY, I was the CTO for FireEye Mandiant for about 3 years before that, and been in the cybersecurity industry about 18 years, give or take. Real quickly, if you're not familiar with EY or Ernst & Young, we are a couple, about $20+ billion organization. We have 200,000+ people across the world. Our cybersecurity practice, give or take, with our risk management practice, is about 15,000 people globally. So inside our cyber practice, we do focus on a lot of different elements. Cybersecurity or software security is one of those elements that we do focus on, and we do have a unique strategic alliance with Microsoft to really how to elevate our clients' experience and bring cutting-edge technology to them to solve some of their hardest challenges. So today, what we're going to talk about is some of those challenges, some of our experiences with Springfield, and hopefully we can shine some light on why this tool can be valuable. So real quick, when we're working with some of the largest clients in the world, some of the challenges that we see typically they run into is really scalability. They have, thousands of millions type of applications throughout their environment, and they really kind of focus on how to address some of the largest risks and get that scale. So when we go in and do a lot of security assessments and testing methodologies and really look at that mission they are looking for, from if it's a focused crown jewel attack of looking at a certain type of application and kind of expanding that through their entire enterprise, we looked at unique ways to bring technology through that technology-enabled services to bring a better value to our clients. And leveraging different tools like Springfield, we're able to do that at mass scale. And what we're going to cover a little bit more today is really how we've done that in the past and what value we can bring there. So I'll give it over to Rishi to talk about it a little bit more.
Thank you, Chad. Let's see, hopefully this thing works. Yep, it does. Thank you, Chad. I'm Rishi Pandey. As it says on the slide there, better photograph of me than obviously in person. Maybe major kudos to our branding marketing folks. But anyways, I'm a senior manager in cybersecurity. I focus exclusively on software security and product security. So we go out to clients, to UI's clients, help them develop and deploy their secure development lifecycle projects. I've spent about 12 years in the industry before coming over to UI, primarily at a financial services company, one of the top 5 banks. Helped deploy their A&P programs and then obviously their software security programs. And been fortunate enough in the last couple of years where I've done the same for a lot of UI clients, mostly in the Fortune 500 realm. So I think we've talked a lot about secure development methodology. I mean, hopefully everyone over here is familiar with the secure development lifecycle that Microsoft has. There's a couple other models, probably everyone knows about them, either BSIM or OpenSAM, that are out there. In effect, all of these models, more or less, I mean, they have minor tweaks or minor changes, but what they're focusing on is how do you integrate security during the development lifecycle, right from the requirements phase through design development, testing, and then obviously once it's in production as well. What we found, obviously, is while people are developing and deploying these frameworks, they have to adopt and adapt it to their environment and their culture. All right, you can't just take the default framework, lift it, and hope that the exact same thing works. So most people will take that. Maybe there's certain elements of it which will work for your company or your enterprise versus certain elements that may not work for you. The other thing that we've also found is, especially in large enterprises, it also depends from business unit to business unit. So there may be a business unit that's doing more agile DevOps type development. There'll be an SDL or a version of SDL that works for them. There's other environments where you're doing probably a little bit more traditional waterfall development. Certainly some of the sectors that were mentioned earlier traditionally try to do a little bit more waterfall development. And in those, the SDL looks slightly different. We've also found a difference, obviously, between those that do web applications versus those that do non-web applications or your typical tech clients. And if you come to fuzzing, in particular in the web application world, I think fuzzing is a problem that's been at least around it's a technology that's been around for about 15 years at its very core. In the web app world, I mean, there are fuzzing tools that will take some kind of input, throw it on your website and see how the website reacts. The challenge has been none of these tools actually work quite well on non-web applications or thick client applications, right? And so your default fuzzers, and there's several open source ones out there as well, your default fuzzers, especially when they're black box fuzzers, take some data, throw it at the input that you see within the application, hope for the application to crash at some point in time, and then once it crashes, it says, here you go, here's a vulnerability that we found. The technology, especially black box or default fuzzing or dumb fuzzing, is not very helpful, definitely not very scalable. I think there's been a lot of challenges, especially as people have tried to adopt and adapt them, and I think we heard about some of those challenges earlier on as well. there's a lot of customization that you need to do. All of a sudden, you're asking security people to understand what a fuzz source is, how big your fuzz source can be, and you get into a lot of things that typically they don't have to do in their development lifecycle. As time's gone on, I think, obviously white box fuzzing, which I think David will cover a lot more in depth, as the technology has come around, and they've really improved results from fuzzing in general. The other thing that we found is, especially if you get into UI type situations where your application's taking UI, you've got to write some kind of a wrapper around these tools to make it actually flexible and work to your particular conditions. So having talked a lot about fuzzing now, obviously there are some advantages to this, right? There's a reason why people are actually doing this. The biggest advantage is that when you actually find a vulnerability using a fuzz tool or a fuzzing tool, it's a vulnerability that you can see. You can say, given this input, under this condition, this application fails. Quite unlike some of the more traditional grep or code scanning technologies, which rely a little bit more on best practices or security guidelines or any of those kind of things, right? So it's a much easier way to show somebody, here you go, here's something that's actually caused a crash versus here's something that may potentially in the future, under a lot of conditions, cause a crash. The other thing that's worked well, I think, is if you have a fuzz source, if you have the right fuzz source, the tools work rather well. The challenge has been with coverage. So one of the things that, especially with dumb fuzzing, if you think about an if-then-else loop, and if you have 5 variables, right, to test all of the conditions in the right way, you need to make sure that your fuzz source is has a certain input for the first 4 variables, and to test a part of the code that will only get executed when the 5th variable changes. So that's been one of the problems. Obviously, the second has been a little bit of a complex logic. I think people get lost in some of the technical details around fuzzing. They don't understand it, so they just throw something, hope that it doesn't fail, and then look at the results and try to fix those. We've known of at least one of the companies that we worked with where they tried to use a fuzzing tool, and the first time around that they used this on all their applications, they came back and they said, oh, we actually have no issues in our code. We've not found a single vulnerability. And that was kind of interesting. It's like either A, your developers are really, really, really good, or B, you didn't use the right fuzz source. And so sure enough, they went back, they looked at it, and they basically had given it blank input and were hoping for something to come back. So I think that's one of the challenges. And the third one has been the length of time. I know this was covered earlier as well, where if you have just one machine kind of going at this, right, think about you want to give it millions of inputs to see how it's going to fail, when it's going to fail. I think obviously moving it to an environment where there are multiple machines that can do this type of testing for you eases some of the challenges with time. So the one thing, or maybe one of the few things that we've noticed is some of the people start mistaking a tool for a program or a service. I think that's one of the challenges that we've faced, where people will take a tool, assume that this tool should be used anywhere, everywhere, at all points in time, and that's the only thing that they should do. One of the best ways, I think, is obviously around creating a program for something like this, right? Figure out what the process is, what process actually works for you within your company, how much is security going to do versus how much is the development team going to do, at what point in time, who calls whom, right? I mean, I don't know if security in every company would be able to actually write code and write wrappers around something like this and be able to execute that. The development team may be able to, but do they actually understand the security impacts of that? So that's something that people need to figure out. You also need to, so if you think about large enterprises, some of them have 1,000 different applications, right, or thousands of applications. What do you do in that case, right? You take all 1,000 applications, pass it through a fuzzer, hope for the best. How long do you pass it through the fuzzer for? Those are all things that you need to think about. And so from a process perspective, obviously figuring out what are your critical applications, how long do you want to run it for, when do you say enough of fuzzing has been done? I know there are some industry recommendations around let a fuzzer run for about a couple of weeks. If it doesn't find anything, well, that's good enough. Or if it finds something, we set the timer again. So those are some of the things that you need to think about. I don't know if these industry recommendations would fit within your enterprise, within your company or not. That's something that you've got to determine. What happens, for example, if you're only making delta changes in your code, right? So if you have a set of code, you've run this through the tool, you make some changes, do you test the whole thing again, or do you just test what is being changed? And those are all decisions that you need to make as part of creating a program. The one thing also I wanted to cover was, where do we see this fuzzing type technologies being helpful and useful? I think one of the biggest industries is obviously independent software vendors, like Microsoft. So we'll have the other place that we see this working is in a IoT type environment. So especially if you're writing these thick client executables, which are going to run somewhere, and then you can either extract the code or you're sending data to another place, and that's something that's interesting. Obviously, P&U, I think some of my former speakers pointed out a particular case study over there, or they've used it in that space. Diversified industrials, obviously. And then finally, we also think that maybe OEMs are a space where this may be useful. So if you think about people who are selling you computers, there's a lot of preloaded software on top of it. Right? How do you know what is the security of that software, right, before you actually buy this computer with multiple pieces of software in it? So that's something else that perhaps we think will be useful in the future, or an industry which will probably adopt it. So before I wrap up, 2 key takeaways. Number one, it's a tool. Think about the program, think about the process around it, especially if you're a large enterprise, large company. Number 2, it's a tool in your toolbox. It's not the only tool that's going to solve your entire SDL problem. So with that, I'll pass it back to Chad.
Yeah, thank you, Reese. Yeah, thank you. So to that point, I want to kind of elaborate a little bit more as the flexible architecture that Springfield sits inside of around the Azure environment allows for extendable use too, right? So if there is other technologies and other tools that helps with that overall life cycle, you can spin them up inside that environment too from what we've seen in the past. Really, the scalability of our strategic alliance with Microsoft really goes way past the software security space, and we continue to provide innovation techniques around this for our clients. And this is just one area that we really are passionate about, and we have a very large practice around our software security, and we continue to keep innovating, keep moving down that path. But what I would say is from a global scale, we really see this really kind of moving the mark and continue to innovate for our clients moving forward too. So, that's all I really wanted to say. I really appreciate everybody's time. I appreciate Microsoft for having us here today, and we continue to look forward to working with everybody. So thank you.
Thanks very much, Rishi and Chad. So now you've heard a little bit about how this has actually been used in practice and where 2 different partners or alliances see this going in the industry. I want to actually give you a little bit more color about what it is that we do and give you a view of what the product actually does. So I'm just going to start by showing you what Project Springfield looks like and how you would use on a day-to-day basis, just like you heard Weston and Mike talk about how they've been using it on a day-to-day basis. at the basic level, Project Springfield gives you a web portal where you can have an overview of all the software you want to test. And if you need to test another piece of software, you push a button saying create job, and that creates another another lab in the cloud waiting for you to test it. Now, once you've actually started testing, we get back some results, and the results are organized in a way that lets you understand how serious are they, what kind of issue is it, and then it gives you instructions on how to reproduce. And thanks to the scalable Azure architecture that we have, thanks to engineering muscle that we've built, you can actually spin up as many of these as you want effectively. So if you have 10 different teams in 10 different parts of the world, they can all use this at the same time. And then I've just created this job. I'll say this is a new lab for fuzzing. And then I'll just save it. And then that's the beginning of testing for yet another piece of code. Now, what happens is we are actually provision a machine in Azure for you. You can actually connect to the machine, and you can then configure it any way you want. You can install the same software that you're going to deploy to your customers, the same software that's going to run in your environment. You can basically test what you ship. So here, we just give you a machine. You connect to it. You can copy a password. I've already connected. And in this case, there's a little wizard which walks you through the process of getting up and running. In this particular demo, I've already uploaded the software to the machine just to save us all some time. But I'm just going to show you what it's like to go through this fuzzing wizard. And you'll see that there's nothing in here that requires you to know anything about security. It's all questions about your code, your application, things that you've already done. So I'll just say, OK, what's next? I am just going to pick the application out. Here we go. I have a demonstration fuzz program. This is my application. I'm going to give it some command line. In this case, the default works, but you can configure it however you like. I need to give some example files. They don't need to be anything special. They can be the same unit test or same regression test you're already using to test your code. The technology we have, as I'll explain in a little bit, takes any input you have and generalizes it in order to find more corner cases in your code. And in this case, I've already uploaded that as well. So there we go. There's my demonstration program. There's my seed files. It wants to know what the, so you can have a directory of seed files. You tell it which extension to look at. These are .bin files, but maybe you have .pdf or some other special format that's unique to your industry and your application. And then we go through a couple of simple questions like, can I rename it? For example, in Microsoft Word hates being renamed. It throws a fit if you do that. So we've actually created these questions in this questionnaire based on our experience at Microsoft over the last 15 years of doing this and sort of bundled it up into something that's sort of a simple yes, no, few things to fill out, and then you push a button and we spin it up. We ask you how long do you think it'll take, and if it takes longer than that, we can notify you. We see, does it close itself? Or if not, do we need to detect if something's been stalled and close it? Can we run it repeatedly? Does it run as a single process? We then check the answers that you've given us to make sure that they're sane and make sure that, that there's no problems or typos. And now this job is done. That is all you need to do to spin up a whole ton of machines in the Azure cloud and get started with fuzzing. And once I push this button, which I just did, the machine goes off, we generalize it, and then we clone the heck out of it, and we add our unique white box fuzzing technology plus a suite of other fuzzing tools. And that entire suite, the entire portfolio of techniques is now working for you right now to come up with a list of things that's wrong so that you can fix it. And then that lets you, as we've heard, sort of repeatedly test until you get down to 0 as part of a global fuzzing program that you can implement in your company, that you can put into your life cycle, that you can put into your automation, and become part of your security practice. And in particular, the last thing I'm just going to show on the product itself, before I talk a little bit more about like how it's been built and what it takes to get up here, is we actually have an API, and for people who sign up, you can get access to it. Oh, right. The Swagger API has been moved. But we actually have an API where everything you see here, every single operation that you see can be turned into a REST API call. We actually have PowerShell scripts available for people who sign up for the preview, so you can actually script all of this. So for example, one of these use cases that we've had inside Microsoft is our colleagues in MSIT, they actually have a responsibility to test the security of things that are purchased or licensed in. And they want to know, before I put this piece of software that someone wants on a really high-value machine, think like a machine that like controls access to Azure data centers. So it's a high-value machine. They want to assess how secure it is. And imagine you had that problem, and you could write PowerShell scripts to just test a whole bunch of different things under different conditions. That's the value that we can provide to you with this technology. So I want to go back now. Now I've sort of shown you what it looks like. I want to go back now and talk a little bit about what it looks like under the hood. We'll have more to share about this in the coming days. But let's see. There it is. This is just a very brief screenshot of what it looks like on our side once you push that button. We're using Azure Resource Manager. We've actually done a lot of work. Our entire team has done a lot of work to build an architecture on top of the latest Azure APIs, including Azure Resource Manager and Service Fabric. And the reason we do that is so that we can have a dynamic configuration of machines and of material in Azure for you. So today, every time you push that button, we spin up all of these different machines, and there's more behind it. But it's something that's built entirely on Azure, and thanks to the work of our team, we have a scalable infrastructure that can really grow as your business needs grow, but can start small. So you start where you need to start, and you go up as you need to go up. And I want to talk a little bit about what the white box fuzzing technology is, because we've heard about it. You've heard about how it solves some of the problems that our colleagues at OSI Soft had. You've heard from Leviathan how it's something that would find some of the issues they found. And you've heard from EY about how it's different from the previous black box fuzzing. I just want to give you a short example of what it is so you can understand it better. So this is a little program, and it will only crash if it's got the specific input BAD exclamation point. There is no other input that will cause this to crash. If you throw random testing, black box testing, like the kind we heard about earlier at this, it's not going to find it. If I give you this program and I just give you the binary, not the source code, and I tell you just try to find this issue by just randomly testing things or by trying to guess what the issue is, you're not going to find it. The only way you would find this is by actually analyzing the binary, actually looking at what the code is doing. That's possible, but it requires skills, it requires time, it requires knowledge. What we've been able to do at Microsoft is we've been able to create artificial intelligence for doing that. And it puts together two unique things. First of all, we have something we call time travel debugging. How many people here have ever seen a car crash? Okay, a couple people have seen a car crash. Imagine you're seeing a car crash and you're trying to figure out what went wrong. Well, you might see that the bumper is dented. You might see that the wheel is turned. But you really have to guess. Now imagine you had a video of the minute prior to that car crash, and you could kind of rewind and see what happened. How many people think that would help you figure out what went wrong? Okay, pretty much everybody, right? Microsoft has that ability for code. We have the ability to run this program on an input, maybe the input good, and we can actually record what is the program doing to that input. We can actually check and say, hey, it compared the first byte to B, the second to A, the third to D, and so on. We can actually write down all of the constraints that have to be true about that input in order for the program to go down this particular path. And then what white box fuzzing does, it puts that together with a revolution in constraint solving that's been underway at Microsoft for the last 10 years. We have a constraint solver that's able to solve this kind of question faster than anything else I know. And what we can say then is, hey, I want to explore more of the state space of this program in a sane way, in an automatic way, doing the same kind of reason that you might do yourself if you were actually reversing this binary. And you can say, well, look, maybe I want to cover the other side of that if statement. I want that if statement to be true. Well, if you're a human being, you'll say, well, okay, clearly that last byte has got to be an exclamation point. And clearly, to even reach here, I have to have the first 3 bytes be BAD. Well, we can write that down, and we can feed it to constraint solver. Now, this is something that if you had told me 15 years ago when I started working in this field that I would be doing today, that we would all be able to do today, I would have told you you were nuts. That kind of problem at scale, it doesn't seem solvable. But today, it is solvable. We actually get a new test case out of this that we can say GOO exclamation point that actually will cover a new path through the program. And we can continue to do this. We can solve multiple constraints, and we create more test cases that systematically explore the state space of the program. And then we feed them back in. And we can create more and more test cases until finally we synthesize the test case that actually causes the crash. So that is white box fuzzing. That is why it finds things that are missed by all their methods. This is the technology that found a third of the fuzzing bugs during the development of Windows 7. And the constraint solving we have is so good that during the development of Windows 8, we asked 3.4 billion questions to the constraint solver, and almost all of them were answered in a tenth of a second. That is the technology that we're bringing to bear. And in order to make it work, in order to make it scale, we had to do significant heavy lifting to get into an Azure service. And we are finally able to make this available to you. So I just want to close by talking a little bit about Microsoft's unique approach and where we fit. Microsoft is building a holistic platform that looks across all aspects of the security problem. You heard Chad from EY talk a little bit about how there's a great deal going on beyond just software security. And you heard Chad from Leviathan talk about how there's a whole aspect of getting really deep into engineering problems that we have to go into in order to solve these problems. Microsoft is building a platform. We're bringing intelligence, like the intelligence in Project Springfield, into this platform. And we're delivering it together with these customers and partners. And that's why we've been very privileged to work with OSIsoft, Leviathan, and EY on this journey. We're very happy to have them here. So in closing, I just want to say thank you all for coming and sort of talk about what you can do next to learn more and what you can do next to be more secure. First of all, the speakers are here. Please meet them, talk to them, learn from them. Second of all, the Springfield booth is working in the expo, and you can come meet the team. And then let me just quickly also show you very quickly, just give you a little bit more color on Swagger. This is the actual list of things that you can do. So the thing you can do is once you sign up for the preview, we can give you access to this list of operations. And these are things that you can write scripts on, that you can integrate into your process in order to say, how do I automatically start fuzzing? But then not more than that, when you think about the program you want to build, Mike, you and I have talked a bit about dashboards. This is something you can use to pull information out of Springfield into a dashboard. This is something you can use to say, hey, how can I monitor fuzzing progress across my entire organization, even if it's globally distributed? And that is sort of where we start, where we have this technology in the cloud that scales with the cloud, that we then work with partners to deliver to you. And so those partners are here. You can meet them. The entire team is here, so if you have questions about how we built this, how we use Azure Resource Manager, how we use Service Fabric, how we get the value of Azure to you, the team is here. Sheikh and William from the team engineering are right there in the back. If you have questions about the technology and the research behind it, our chief scientist, Patrice, is here. And then, of course, we have more security sessions where you can learn more about the Microsoft story. And then finally, the best way to learn more about Springfield, the best way to get your questions answered, to get access to it, is to go to this URL and sign up. So if you sign up, we will be able to go through and figure out who can benefit most from technology, get in touch with you, get you started. And then even if it's not a fit right now, signing up and telling us what you need helps us prioritize our decisions in the future. So please do that. And so with that, I'd like to just remind everyone to just sort of close on that. And sorry, I just sort of say thank you very much for that, for your time. Thank you very much for coming. And then let's just break and have a chance to meet the speakers and have some follow-up discussion. Thank you.